So today's class we are going to study about introduction to adaptive filter and its applications. So if you see the general filter, so the filter has the characteristics that it will allow only the particular frequency to pass through. So in the filters, if you see there are the classical filters and optimal filters. So the classical filters are always it is a frequency selective filters like low pass, band pass, high pass and notch filter. Those filters it allow only the particular frequency to pass through. So that's why it is called as a classical filters. But in the case of optimal filter design, so it is not like frequency selective. So even when the signal is buried with some noise, we can able to retrieve back the original signal by applying this optimal filter design. So the main aim in this optimal filter design is it will minimize the mean squared value of the error signal. So first of all, the error signal will be calculated. We have to square that error signal and find out the mean value for the squared error signal. So if you see the adaptive filter, it is a special kind of filter in which for any kind of a non-stationary signal, what is meant by non-stationary signal means any signal with statistical characteristics which varies with time. So that means if the input output characteristics varies with respect to time, so those signals we call it as non-stationary signal. So to process this non-stationary signal, this adaptive filter is used. So what is meant by adaptive filter is it is a filter which adjusts characteristics according to the input signal. So it adjusts its characteristic according to the whatever the nature of the input signal. So that is called adaptive filter. So this adaptive filter it is function using an adaptation algorithm is there. So here basically it receives the signal and then process the signal so that we can able to eliminate completely the noise and retrieve back the original signal back. So in this adaptive filter process there are two steps involved. One is the filtering process, another one is adaptation process. So in the filtering process it will produce the output when you give the input signal, and the next in terms of adaptation process we can able to filter the parameters, filter transfer function by using the time varying environment. So first of all here there is an optimization criteria is used. So what is the optimization criteria is we have to calculate the error signal. So error signal means it is the difference between the output signal and the input signal, that is the error signal. So we have to calculate the error signal, square that error signal and find out the average value of the squared error signal. So that is called as optimization criteria. Based on the optimization criteria only this adaptation process continues. So if you see some of the application of the adaptive filter, one is to identify the unknown model or unknown plant. So this block diagram illustrates the system identification. So here we see the plant is unknown. The input is given to an adaptive filter. It is the system input is given to the plant as well as to the adaptive filter. The adaptive filter it will adjust the weights according to the input signal and produce the output which is called Y. Y is called the actual output. And we have the desired output. We know what is the desired output should be. And the desired output is given by D. Now we have a comparator. This comparator it will compare the actual output and desired output and calculates produce a error signal. So when the error is 0, we can able to identify the system output. When the error is maximum, so that error signal will be fed back to the adaptive filter. Again, the adaptive filter will adjust the weights according to the input signal and it will produce the actual output. So like that, the process will continue iteration by iteration until we can able to identify what kind of system or what plant it is. And in the next application, if you see interference cancellation, so here example, if there is any echo which is present in the signal, or example in the case of hands-free car phone or aircraft headphones, we can use this adaptive filter. So if you see the primary signal will be the speech signal and the reference signal is the speech signal plus the noise. So that will be sent to the adaptive filter. The adaptive filter it will adjust the weight according to the input signal and produce the actual output called Y, and the desired output is speech signal. So this will comparator will compare and produce the output error signal as an output. If the error is 0, we can able to easily get the system output 1. Otherwise, when the error is maximum, it is error signal is fed back to the adaptive filter so that the filter will adjust the weights according to the input signal. So the ultimate aim in particularly in aircraft headphones here, the pilot will be speaking speech signal should be heard to the other people. So in the case of noise is present, they'll have the aircraft headphones. In that, adaptive filters will be kept so that this will filter any unknown noise, which is known noise or unknown noise, which is present, and the mind it can able to hear only the speech signal. So the ultimate aim of this particular application is the noise interference noise will be cancelled. Only the signal will be enhanced, and it will be heard here. In the next one, so if you see the adaptive filter, it can be implemented using an adaptive signal processor. So if you see this input signal, it is going to adaptive FIR digital filter, which will gives you the output called Y of k. And this is given to a comparator, which will compare the output signal with the desired signal and produce the error signal, which is denoted by E of k. So the adaptation algorithm here, it will find out the difference between the desired signal and actual output, and the filter is nothing but the filter is applied to the input signal and to get the output signal called Y of k. So I said, as I said earlier, the LMS algorithm is an important one. So this is an adaptation algorithm. So LMS represents least mean squared algorithm. So it works based on the deepest descent technique. So that means in here, the steepest descent means. So here there is a surface is present, we can able to calculate the difference in the intensity between the two surface, so that we call it as a gradient. So while you're calculating the gradient, we calculate the gradient of the error surface, and it will estimated for every iteration. So if you see the least mean square algorithm, this is an algorithm, this is a formula to find out the LMS algorithm. So what is the new weights, the updated weights equal to the old weight vector plus the learning rate parameter into the input vector multiplied by the error signal. So this is the formula to calculate each time, each iteration you'll be calculating the new weights using this formula, old weight vector plus learning rate parameter called new plus into input signal into the error signal. So if you see this LMS algorithm steps, first we have the filter output y of n, it is given by this equation. Then we estimate the error signal is the desired output minus the actual output. Then that LMS algorithm is the new weights wk of n plus 1 equal to wk of n, learning rate parameter nu, and u of n minus k is the input vector into the error signal. So this is the adaptation algorithm to implement in the adaptive filter. So the stability of the LMS algorithm, it is convergent only when the step size nu within varies between 0 to 2 by lambda max. Lambda max is nothing but it is the eigenvalue of the correlation matrix of the input data. So always the nu should be within the range of 0 to 2 by input signal power in order to obtain the stability of the system. So if you use the larger step size, it will increase the adaptation rate and increases the error also, mean squared error also. Thank you.